Welcome, I'm Mark Gallier with the Bosch training team. This video will cover the standard features and options for the newest Bosch geothermal heat pump. It's the GreenSource CDI Series SM model. We will also go step by step through some of the key installation and setup procedures. The SM model is the first in a series of new products. It is a water-to-air heat pump. It is currently available in vertical, horizontal, and counterflow package models. It is available in capacities from 2 through 6 ton, and this video will cover the vertical model you see here today. It has an entering fluid operating range in heating from 20 to 90 degrees, in cooling from 30 to 120 degrees. It is suitable for all applications, including water loop or cooling tower boiler applications, groundwater or well water systems, and then the ground loop, closed loop applications. The SM model provides the best combination of performance and efficiency available in the market today. It is loaded with great standard features and has a wide range of optional features available, and we will cover all of those throughout this video. First thing we'll do is unpack the unit. When you get your new SM unit, you will notice the improvements that have been made in the packaging to help reduce freight damage. The first step is to cut along the upper dotted lines on all 4 sides of the cardboard box. Be sure not to cut more than 1 inch deep. Once you cut along the dotted line along the top of the box, you can remove the top. Next, cut along the dotted lines on the bottom, then lift the outer cardboard sleeve off of the unit. You will notice that the filter rack comes in a separate box so that it can be mounted in the left-hand or right-hand position. Go ahead and set it to the side for now, and we will get back to that later. Next, remove and discard the cardboard sleeves and padded cardboard top. Once you do that, you can remove and discard the plastic bag that covers the unit. You can set those aside for now, and then remove and discard the brackets securing the unit to the pallet. There are 4 brackets, 1 on each corner, with 4 screws holding each bracket. Once you remove the screws and remove the brackets, you do not need to put the screws back into the unit. There will be corner protectors that will be installed on the unit before it is set into place. Then once you do that, carefully remove the unit from the pallet, and it is ready to go through the conversion process at this point. Now that we have the unit unpacked, let's take a look at some of the cabinet features. As you can see, the SM model comes with pre-painted white panels for a clean appliance finish. One of the key new features is the convertibility of the cabinet. The vertical unit comes shipped with a left-hand return air connection and a top supply air connection. It can be field converted to right-hand return air connection in just a few easy steps, which I will cover in detail. It can also be converted from top supply air connection to a back supply air connection or a side supply air connection, which I will also cover in detail. The horizontal units must be ordered either left-hand or right-hand return air connection and is not field convertible. The unit is shipped in the end supply air configuration and can be field converted to side supply air connection. The counterflow models are dedicated left or right-hand air return air connection and bottom supply air connection and are not field convertible. Other cabinet features include corners that have 45-degree angles. Corner covers are shipped in a separate bag and will be installed right before the unit is set in place. Another feature is that there are no visible screws. A cupboard called the belt can be easily removed using a small screwdriver inserted into a slot to release the catch. Screws can now be accessed to remove the panels. Access panels have handles for easy removal. The water connections are located on the side of the unit so that they do not have to be relocated when converting the unit from left-hand return air to right-hand. The condensate drain connection is located on the corner panel. It is connected to the internal drain with a barb type of fitting and can be easily relocated during the field conversion. Something else that is new is an LCD display located on the blower access panel that will display any faults that may be present while the system is operating. Next, we will remove the access panels and take a look at the standard features inside the cabinet. When removing the blower access panel, you will need to disconnect the plug to the LCD. The first feature I want to point out is the cabinet insulation. It is insulated with a closed cell foam insulation. Like the TA model, the compressor is mounted to a floating base pan, which also uses a high-density foam to isolate the compressor from the cabinet. The combination of the closed cell foam insulation inside the cabinet and the compressor floating base pan make it the quietest geothermal heat pump in the industry. Our refrigerant system includes the Copeland 2-stage compressor. The air coil is tin-plated, and the condensate drain pan is stainless steel for greater corrosion protection. The unit comes standard with a copper water to refrigerant heat exchanger, and an optional Cooper nickel heat exchanger is available for applications where water quality is in question. Other standard components are reversing valve, bi-flow dryer, and bi-flow thermal expansion valve. The unit comes standard with a constant torque, high efficiency motor. The variable speed constant volume motor is also available as an optional feature. Like the TA series, the SM is equipped with a unit protection module or UPM board. The UPM monitors safeties, controls compressor operation, and reports faults. The standard safeties include low and high pressure switches located in the refrigerant lines and condensate overflow protection. Two great new standard features are water coil and air coil freeze protection. The water coil sensor is located on the refrigerant line between the TXV and the water coil. The air coil sensor is located on the refrigerant line between the air coil and the thermal expansion valve. Both are set at a default temperature lockout of 30 degrees. Some of the factory installed options available are the Cooper nickel coil and the variable speed constant volume motor mentioned earlier, as well as hot water heat recovery packages, hot gas reheat, internal electric heat, and there is a complete list of factory and field installed options that are available in the list price book. Next, we will talk about field converting the unit. Instructions for field converting the horizontal unit supply air connections are illustrated in the Installation and Maintenance or I&M manual beginning on page 6. To convert the vertical unit, begin by checking the steps required using the table on page 14. At the top of the table are all the possible configurations for the vertical package. There are a total of 6. In each of the illustrations at the top of the page, number 1 represents the return air connection. Number 2 is the electrical box or E-box, which as you face that box is the front of the unit. And number 3 is the supply air connection. The left side of the table has each of the conversion steps and references the page number where they can be found in the I&M. There will be an X in the box where the desired configuration and each step intersect if that step is required. The default position, or as it is shipped from the factory, or left-hand return air connection, top supply air connection, only requires you to do something if you have the hot water heat recovery package option installed at the factory. The HRP switch is shipped loose so that it can be installed on the front of the unit in the desired configuration. Once you have the HRP switch installed, you can attach the filter rack so that you have access to the front of the filter rack in the left-hand position. At that point, you are all set and ready to install the corner protectors and put the unit in place. One of the most common field conversions will most likely be from left return air connection to right return with top supply air connection. There are 4 easy steps of instructions for a unit equipped with standard features. We have a unit that has factory installed HRP, so that will add a set of instructions. We also have a factory installed electric heater, which will add an additional set of instructions for a total of 6 steps in the conversion process. In the first set of instructions for converting from left hand to right hand, all of the access panels should be removed to access the internal components. The second set of instructions is the e-box reconfiguration from the front of the unit in left hand to the front of the unit in right hand position. Simply remove the front cover from the e-box. Disconnect all of the electrical plugs. Remove the two screws from the base of the e-box. Remove the e-box from the cabinet. Rotate the cabinet 180 degrees and reinstall the e-box. Because we have the internal electric heat option installed on this unit, there is a third set of instructions that will need to be completed, and that is the relocation of the electric heat components. Those instructions begin on page 21 of the I&M manual. First, identify the components. They include the electric heat e-box and the electric heat elements. First, remove and retain the electric heat element cover by removing the 4 screws. Next, disconnect the high voltage wiring at the electric heat elements. Once the wires are removed, remove and retain the electric heat elements from the blower collar. Once the elements are removed, disconnect the main electrical e-box plug that is located just outside of the heater e-box in the blower compartment. Once that plug is disconnected, remove and retain the electric heat e-box by removing the 2 screws in the side of the box. Once the e-box and the elements are removed, you can rotate the unit 180 degrees so that the return air is on the right-hand side of the unit and reinstall the electric e-box in the new location illustrated in figure 77 on page 22. Remove and retain the blower collar covers shown in figure 78 on the front of the blower collar in the new position. Reinstall those covers in the openings on the opposite side or the original side of the blower collar. Once that is done, reinstall the electric heat elements in the new location, ensuring that the high temperature cutouts are located on the left side. Once the heating elements are reinstalled in the new location, the next step is to route all of the wiring from the E-box back to the electric heaters and install in the new position. Connect the wiring harness to the connector on the side of the electrical E-box, and then reconnect the high voltage wiring from the E-box to the heating elements, matching wire number to the terminals as shown in figure 81 on page 23. Once that is complete, you can reinstall the electric heat element covers. The fourth set of instructions in this conversion is the condensate drain relocation. So when configuring from left hand to right hand, we have to relocate it from the front left as you face the front of the unit in left hand to the front right as you face the front of the unit in right hand position. The fifth set of instructions is for the HRP switch, and this is only needed on the units with factory installed hot water heat recovery packages as we have on this model. The disconnect switch is shipped loose inside the unit E-box, and it can be connected to either the front right corner post or the back right corner post when converting it to right-hand return. From the inside of the unit, remove the two wires connected to the HRP pump disconnect switch. Identify a rectangular knockout and remove it on the right front corner panel in the right-hand position. Install the HRP switch into the knockout and reconnect the switch wires. And then the sixth and final set of instructions is to reinstall all of the access panels. At this point, the unit is now ready to be placed in the right-hand return air, top supply air connection configuration, and the corner post protectors installed. When you have an application where a side or back supply air connection is needed and electric heat is required, you must use a duct heater installed in the supply air duct instead of internal electric heat. This also applies to the horizontal model when converting from end to side supply air connection. If internal electric heat is already installed from the factory, the electric heaters and electric heat E-box must be removed. Please call technical support in Fort Lauderdale to receive instructions for this process. For the purpose of this video, I am going to remove these components to demonstrate the blower conversion. I will demonstrate the conversion with a right-hand return, but the same steps will be followed for both left-hand and right-hand return configurations. The first step is to remove all of the access panels so that you can easily get to all of the components. Then remove and retain the diagonal support brackets on the front and the back sides of the unit so that you can have easy access to all of the components. Next, unplug the electrical connections of the blower motor and the ground wire connected to the blower housing. Then remove and retain the blower, motor and inlet ring assembly by removing 3 bolts that secure the blower motor bracket and screws securing the blower inlet ring. And then carefully remove the blower and motor assembly. Once this is done, take a scrap piece of cardboard from the unit packaging and place between the blower and the air coil so that it cannot be damaged during the blower conversion. Next, remove the screws on both sides of the blower, securing the vertical blower bracket to the horizontal support. Then you should be able to remove and retain the blower assembly by lifting up. Remove and retain the vertical brackets from the blower by removing the 4 screws, 2 on each side of the blower. Next, remove and discard the blower collar. Then remove and retain the side panel blower opening cover by removing the 6 Phillip head screws, also illustrated in figure 53 on page 17. Then reinstall the blower opening cover in the top panel, as illustrated in figure 55. Next, if you're converting to back blower connections, you would remove the horizontal blower support brackets by removing the 4 screws and relocating the brackets to the back of the unit. But in this case, we are installing the blower in the side supply air connection, so this step is not needed. Reinstall the vertical brackets in the new orientation. You can see this illustrated in figure 59 on page 18. Once the blower assembly is in the new location, reinstall the blower motor and the inlet ring using the same steps that we used to disassemble it. reconnect the blower motor electrical plug and ground wires. And then next reinstall the diagonal brackets. Once the diagonal brackets are reinstalled, the blower relocation is complete. If all our other steps are complete, you can now reinstall the panels. Install the corner caps, and now the unit is ready to be installed. The corner protectors or corner caps are labeled. You can use the illustration on page 25 of the I&M to identify the location for each of the caps. You simply remove the adhesive backing and install each cap on the corners. That concludes our demonstration of field converting our return air and our supply air connections. The steps that we took included a lot of extra factory installed options, so there are many steps that we covered that you may not have to do in the field. So make sure you consult the installation and maintenance manual and follow the steps that fit your application. So once everything's complete and all the panels are back on and you've installed your corner caps in the return air filter grill, our filter rack in place. Well, there's one more thing you might want to do before you set the equipment in the mechanical room or where you're going to install it. There are duct flanges that are shipped in the folded down position, and they're manufactured what we call origami style, where you can simply take a hand seamer or a good pair of lineman pliers and bend those duct flanges into place. You just simply put your hand seamers up against the perforated section of the duct flange and bend it into place all the way around before you set it into place and make your duct connections. Once you've field converted your unit to fit your application and you've set it in place and made your duct connections, the next step would be to run your electrical connections and your water connections to the equipment. We've highlighted all of those processes in our TA series installation video, and they'll be very similar to what you will do with the SM model, so we will not repeat that in this video. Knockouts provided for both high and low voltage connections to the equipment, and the water connections we looked at earlier in this video located underneath the return air connection on the side of the unit. So once you've made your electrical and your water connections to the unit, the next step is setting up all of the boards. And then the steps after that include startup and commissioning of the product. Next, we'll cover the setup of the CTM or the standard motor, and then we will talk about the setup of the variable speed motor, which is a factory installed option, which is included on this SM model. After that, we'll go through the setup procedures for the UPM board. The constant torque or CTM motor is the standard blower motor on the new GreenSource SM model. The CTM is similar to the variable speed motor in that it is a brushless DC motor, it has a permanent magnet rotor, and it has the same efficiency as the variable speed motor. There are several things that are different about the CTM. First, it is a one-piece motor with the electronics built into the back of the motor. It is a little bit longer than a standard PSC motor, but more compact than the variable speed. It is programmed for constant torque instead of constant volume and does not adjust for changes in static pressure. It also does not ramp up and down like the variable speed. There is a connector on the back of the motor that has 4 wires. 2 of those wires provide 230 volts or line volts to the motor at all times, anytime the power is applied to the unit. There is also a 24 volt common and a ground wire. It has up to 5 pre-programmed speed or torque taps labeled 1 through 5. A 24 volt AC input applied to one of the programmed speed taps at a time will run the motor at a constant torque. The motor speed is adjusted by simply manually moving the wires to the speed taps from one tap to another. One of the new features of the SM model is that the motor speed taps can be changed in the electrical box or the E-box via a 6-pin connector labeled P20. You can see that illustrated in figure 120 on page 67 of the installation and maintenance manual. From the factory, motor terminal number 2 is connected for part load and fan only operation, and number 4 is connected for full load operation. The CFM should be verified by comparing the measured external static pressure to the airflow tables located on page 58 of the installation and maintenance manual. One of the factory installed options that is available is the variable speed motor. The variable speed motor allows us to have the option of cool to dehumidify or passive dehumidification. The variable speed motor has 2 connectors on the back of the motor module. There is a 5-pin connector with 3 wires running to it that provide line voltage to the motor anytime power is applied to the unit. The other connector is a 16-pin wiring connector which provides low voltage inputs to turn the motor on and off. That 16-pin connector is connected to a motor control interface board. It changes the speeds and operation of the motor based on inputs provided by your thermostat to the terminal block on the motor control interface board. If you have a model that is not equipped with variable speed but with the standard CTM motor, the low voltage terminal blocks will be made via a plug, very similar to the one I'm holding in my hand. If you have the variable speed model with the motor control interface, this plug is actually attached to the motor control interface board. So you can easily make your thermostat connections, and once you make your connections, you can plug it into the connector on the board. The green connector that plugs into the MCI or motor control interface is for dehumidification. We'll talk about that option. And then the blue connector is for your red and your common wires coming from your control. Over to the left of the thermostat block, you will notice several wires connected to the board. These are the outputs to the different components in the system. Right next to those wires is a row of LEDs. You have green LEDs and red LEDs, which will be illuminated depending on the mode of operation. In the middle of the board above the terminal block, you'll see a red LED labeled CFM. This light will flash one time for every 100 CFM of air that is being demanded from the control. Over to the right of the thermostat block, just below the 16-pin connector, is a set of dip switches labeled CFM. The on position is the left-hand position and the off position is the right-hand position. If you look at the blower tables on page 59 of the installation and maintenance manual, you can see that all of the SM models currently should be in the on position in position A. So dip switch A should be in the on position. Dip switches B, C, and D should be in the off position. But always consult the installation and maintenance manual for your model to make sure that is the correct positioning. Over to the right of that set of dip switches are 4 more dip switches labeled adjust. Here again, the left position is on, the right position is off. From the factory, the top switch labeled norm or normal is in the on position, which means you will get your nominal CFM listed in the blower tables on page 59. If you put it in the plus switch in the on position, that will increase the CFM by 15%. If you put the minus dip switch in the on position, you'll get 15% less CFM. There is also a test dip switch when placed in the on position and given a fan call from the thermostat, the motor should ramp up to 100% of the CFM. Just below those dip switches is one additional dip switch for hot gas reheat. There are 2 different types of dehumidification, one which is passive, which we talked about a little bit earlier, so that you can operate with this variable speed motor when you have a humidity enabled control. The control will send a 24-volt signal to the board during a call for dehumidification, and while the unit is operating and cooling, it will reduce the CFM of the motor by up to 30%. The other option is hot gas reheat, which is not installed on this unit, and you should consult the installation and maintenance manual for the proper setup for that mode of operation. Next, we'll talk about the unit protection module, or the UPM board. The UPM monitors our safeties, controls compressor operation, and it reports faults. We talked about some of the standard safeties that are incorporated into the SM models. The new standard freeze protection for both the water coil and the air coil plug into the UPM at the bottom of the board. Just above where those sensors plug in is a set of 4 dip switches, and we'll talk about the function and where to set those dip switches before startup. Just above that set of dip switches are 2 resistors, one marked Freeze 1 and one marked Freeze 2. The sensors come default at 30 degrees, so if the water or air temperature reaches near freezing, the unit will go into a soft lockout when those sensors reach 30 degrees. On the water coil, if you're operating it on a closed loop system with glycol and you want to operate it below 30 degrees, you have to cut the resistor that is labeled Freeze 1, and it will reduce the cutout temperature to 15 degrees. Some of the other features of the UPM board include an anti-short cycle timer, which is a 5-minute delay on brake timer to prevent compressor short cycling. It also has a random start delay that ranges from 270 to 300 seconds. Also included in the board is a low pressure bypass timer. The compressor will be allowed to continue to operate for 2 minutes after the low pressure switch opens in order to prevent nuisance trips. There is also brownout and surge protection built into the board that monitors low voltage and will prevent the compressor from operating if the voltage drops below 18 volts or rises above 30 volts AC. Like the TA series, the UPM is equipped with intelligent reset. If any of the safeties open, the unit will go into a soft lockout. It can go into a soft lockout 2 times in a 60-minute period, and then the unit will go into a hard lockout. You can also set it to have 4 soft lockouts in a 60-minute period instead of 2 by moving dip switch number 4 to the left-hand position. Then once a unit goes into a hard lockout, that lock can be taken out of a lockout by resetting the thermostat. You can also set dip switch number 2 so that it takes a 24-volt power reset in order to bring it out of a hard lockout. So you have the ability to adjust this slightly using dip switches 3 and 4. Also, anytime there is a fault or a safety that has tripped and it is in a soft lockout or a hard lockout, we have an alarm output. It's located at the bottom of the board on these 2 open terminals. It's just a set of dry contacts. Anytime it's in a fault, it will pulse and open and close those contacts. You can also set dip switch number 2 from pulse to continuous, and those contacts will remain closed continuously during a lockout or a fault. Dip switch number 4, labeled test, comes in the no position. If you move it to the yes position and recycle power, it will shorten all of the time delays to 10 seconds so that you can diagnose problems without having to wait on the time delays to expire. For a complete list of all of the functions of the UPM board and all of the options available for connecting to your controls, please consult the installation and maintenance manual. Another great feature of the UPM board is an output from that board to the LCD display on the front of the unit. This allows you to see any faults that may be present on the board without removing the lower panel to look at the board itself. This concludes this video on the new SM model. We've covered some of the key features, a couple of ways to field convert the unit, and some of the setup procedures for a couple of the boards. Always consult the most current installation and maintenance manual for all of the setup information and installation information, as well as sequence of operation and maintenance.